Hello, students. Okay, let's now see these two examples. From where we stop at example 2. If you have not watched the first and second example, please ensure you do that before coming to this. So let's get started. The question says, a bridge made of steel is 600 meters long. What is the daily variation in its length if the night time and daytime temperature are 10 degrees Celsius and 30 degrees Celsius respectively, given that the coefficient of linear expansivity of steel is this amount? So what did I say you should do first? Identify your parameters. So a bridge made of steel is 600 meters. Here is my original length, L0. What is the daily variation? So the term variation simply means what? Change. Is that taken? So that is what we are looking for, is change in length. If the nighttime and daytime temperature are this and this respectively, the first one is nighttime when the temperature is down. So here is my theta 1. And this one is the daytime when the temperature is high, theta 2. So I have my alpha. So let's go and solve. Solution. Those data given to me, I normally call it known. So I know my L0 to be equal to 600 meter, and I know my theta 1. Theta 1 is 10 degrees Celsius. I know my theta 2 to be what? 30 degrees Celsius. And I know my alpha for steel to be equal to 0.0000012 per degree Celsius. So what is the unknown? Unknown, the only unknown I have is what? Variation in length, which is the same thing as my change in length. Are we together? So the next step is to recall your formula. Recall that alpha is equal to change in length all over original length into change in temperature, theta 2 minus theta 1. Theta 2, final temperature, theta 1, original temperature or initial temperature. Are we together? Now, the next thing, you input your value. I have 0.000012 is equal to change in length all over. Original length is 600 into final temperature, theta 2 is 30 minus 10 the initial temperature. Come to this side. So all I need to do here is to what? Cross multiply. I have my change in length is equal to this multiplied by the whole of this, 0.000012 multiplied by 600. 30 minus 10, that will give us what? 20. So if you multiply the whole together, that will give you the variation, which is the same thing as change in length they are asking for you to calculate. So I'll have 0.000012 144 meter as the variation. I hope this is understood. This is what we have. I hope it is clear. So now let's look at the second problem. We have a steel bars, each of length 3 meter at 29 degrees Celsius, are to be used for constructing a rail line. If the linear expansivity of steel is this per Kelvin, calculate the safety gap that must be left between successive bars if the highest temperature expected is 41 degrees Celsius. Like I normally do, I'll identify what? My parameters. What are the parameters here? A steel bars, each of the length, here will be my what? Original length. At this temperature, here is the temperature before heated by what? By sun, heat from the sun. Heated it maybe during the what? The day. So I call this one as my θ1, original temperature. If the linear expansivity is this, already here is my alpha, calculate the safety gap that must be left between it if the highest temperature expected, maybe that particular day, the highest temperature is what? 41. Here is my final temperature. Now, the question here is, what is safety gap? Now, that is, you ask yourself, what is safety gap? Because in the whole of your formula that we have been using, there's nowhere they quoted what? Safety gap. But don't panic. Just the way we have variation, daily variation that we say is the same thing, change in length is the same thing. But before we move to that, I'll just dive into the application of what? Of thermal expansivity, or the consequences of what? Thermal expansivity. One of it is what? Is that what? Expansion of metal. In a rail line, rail lines are made up of metal. So, and there's tendency of what? Expansion and contraction during the day and what? During the night. So, if a safety gap is not put into consideration, a safety gap is just like a kind of what? Allowance given for what? That kind of expansion, variation. Because in the day, we have expansion as a result of what? Heat from the sun. And in the night, we have contraction. So if there's no safety gap or a kind of allowance given by the contractors or the engineers, then there's tendency of the what? Of the rail line to derail, and which can result to what? Accident along the line. So the essence of putting the safety gap is to what? Is to create allowances that will prevent what? Such consequences such as what? Derailing. Are we together? So that safety gap is nothing but what? The change in length. So solution. As usual, you have to itemize what you have. The known, we have original length is known to be given as what? 3 meter. And the original temperature, initial temperature is what? 29 degrees Celsius. And they give me my linear expansivity to be 1.0 times 10 raised to power minus 5 per Kelvin. Then they give us the final temperature to be 41 degrees Celsius. So what is the unknown? Unknown is safety gap. Safety gap, which is the same thing as what? Change in length. Are we together? The same thing as the change in length. So the next thing, recall that alpha is equal to change in length all over what? Original length into what? Theta 2 minus theta 1. So the next thing, input your values. I have 1.0 times 10 raised to power minus 5 is equal to change in length all over original length is 3 into 41 minus what? Minus 29. Then make change in length subject to the formula by cross multiplying. If I cross multiply, I have change in length is equal to 1.0 times 10 raised to power minus 5 multiplied by 3 multiplied by the differences of what? 41 and 29. That will give us 21. Right? So now, just multiply everything together. Right? So I'm going to have here to be this, which is equal to multiply them together. I have it to be 3.6 times 10 raised to power minus 4 meter. Are we together? So this is how to approach what? Questions where you are not given direct way of solving your what? Change in length. They could have just called it change in length, which is very straightforward, but no, they say daily variation, so don't panic. Here, they could have just said change in length, but no, they say safety gap, don't panic. It's still the same change in length they are asking you to calculate.